This is the second video for sample exam number 1 for Math 107. This is a question on evaluating the difference quotient, and the difference quotient is right here. Let me get a highlighter. It's right here, and you will be given this formula. You do not have to memorize it, you only have to know how to use it. So how do you use the formula? You're given f of x here, so the first term is f of x plus h. Now in function notation, that means every place there's an x, I have to put x plus h. So this is 3, x plus h plus 9. Then work out the algebra of this. 3x plus 3h plus 9. Okay, that's all you can do there. Now the next is to subtract the original function. And this leads to errors. So I'm going to go ahead and assemble it right now. I have 3x plus 3h plus 9. And I have to subtract this whole function. So it's really negative the whole thing. 3x plus 9 divided by h. See, if you just write the following, it's going to be wrong. You might go 3x plus 3h plus 9, and then if you put a negative sign, 3x plus 9, then you'll be adding in the 9 instead of subtracting it off. So when you distribute this negative sign through, oh, I should have put that out there. Well, okay, let me do it right now. Okay, I'm going to get rid of this. And I'm going to go here and carry through that negative sign. So I have 3x plus 3h plus 9. Now, minus 3x minus 9. Obviously, if you can remember to do that, you don't have to write it in parentheses. But that means this right here means subtract the entire function, not just the 3x, but everything. All right. So what happens as a result? The 3x's go away, the 9's cancel off, and you end up with 3h over h, which is 3. If there's a square, you have to FOIL it out. Okay, here's another fun one. In this case, you have to be able to graph a piecewise function. So how does a piecewise function work? The piecewise functions has different values, different pieces, depending on x. So when x lies between minus 5 and minus 3, its value is negative 9. When x is between 3 and 5, its value is 3. Those are the easy ones. In this case, you just look at it line by line by line. Let me put the highlighter up here so you can get the idea of it. So here is the first, it's like a little mini problem. Then here's the second one, and you graph that. I wonder if blue will show through. Okay. No, that did not work so good. How about red? Alright, there we go. So each one is a little mini problem in themselves. The ones where f of x is a constant, like minus 9 or 3, those are very easy to graph. So here we've got between 5, so you have to mark up your x-axis. This is your x-axis, here's your y-axis. Okay, if that's 1, 2, I should have made this bigger, 3, 4, and here's 5. Okay, going in the other direction, minus 1, minus 2, minus 3, minus 5 here. Alright, and so here's my 3. As long as x is between minus 5 and negative 3, it has a value of negative 9. Okay, so I start here and I go here, and so you see it's a constant value. Because the minus 5 is included, I put a solid dot. The minus 3 is not included, you could leave it as it is or put an open circle. Alright, now go down to the one marked in red because that's easy as well. This is minus 9 here. We'll go up to 3. Okay. Now, I should have color-coded this, but, well, thought of it too late. Between 3 and 5, including the endpoints, it has a value of 3. So here's 3. And 5. So, you see, that's why the function looks between 3 and 5. Here's the 3. Now, that should be fairly easy. Now let's look in between the function, and you see the one in green is a little bit different than the others because it's not a constant. F of x is equal to 2x minus 3 for negative 3 less than x less than 3. Right? How do you handle this? Here's how you handle it. You evaluate the function at the endpoints. So here's the first endpoint, minus 3. Put that in the equation. So we look at minus 3. We have 2 times negative 3 minus 3. Okay, that's minus 6 minus 3 gives me negative 9. Now go to the other endpoint, which is here, and evaluate the function again, f at 3. That's going to be 2 times 3 minus 3. In this case, it's a continuous function. It ends up as 3. So I'm going to go ahead and graph it. It includes this endpoint. It doesn't include either endpoint. So this is an open circle and it never gets closed in, and here is your function, a straight line between them. It's a straight line because this is linear. 2x minus 3 is a linear equation. So again, to reiterate a little bit, piecewise functions are made up of little tiny mini problems. Look at them and figure out the range of x, or the domain of x here, that pertains to this particular problem, and mark it off on your graph. So here was minus 5 and minus 3. Right? In this case, the function is a constant, so you can draw in a straight line there because it's minus 9 for those values of x. Same thing here. It was constant 3 for these values of x, so I just put it in as a straight line, which is what it is. If there's an x in the function, the little mini problem here, you evaluate it at the endpoints, at the minus 3 and the 3. That will give you 2 points, and draw a line between them. And here's a computer graph of the solution. You see it's minus 9. Oops, let me get a pencil. You see how right through here it's minus 9. You can't see the scale, so good, but this is from minus 5 to minus 3. You see it has a value of 3 for x equal 3, between x equal 3 and x equal 5. Okay, so right in here it's constant 3, and then because it has there's a linear function between them, you evaluate at the endpoints. The lines may or may not match up. There might be jumps in them. In this case, there's no jump. Here you'll be given a graph of a function, and you need to compute the slope, and then write the function, it's going to be linear, as y equals mx plus b, in that slope-intercept form. So first we have to compute m. This will not be given. You need to know this. The slope is delta y over delta x. Rise over run. Be sure you put the y in the numerator and the x in the denominator. So I find the values up here, and I just subtract the y values, subtract the x values, and I get a 2 in this case. That's the slope. So let me write that. So when you go to write your expression, you've got y equals mx plus b. Is what you want to write. You know m turned out to be 2, so you can substitute 2. And now to find b, b is the value of the graph, value of the function, when x is 0. That means it is the y-axis intercept, and it's given right here by 4. You can read it right off this graph. It's that point. So y equals 2x plus 4, and you can indeed see if x is 0, y would be 4. Now for the 2 points that are shown on the graph, you need to find the midpoint. The midpoint is a point, so it has 2 values, an x value and a y value. I call them x mid, or you could write them x with a bar over it. You need to know these equations. They won't be given to you. So to find the midpoint between 2 values of x, you add them together and divide by 2. Same for the y. That gives you a midpoint, and the midpoint again has an x and a y value. So it's ordered pair, x, y. Put the x value here and the y value here. Now you need to compute the distance between the 2 points shown on that graph. And the distance formula is right here. I used it as distance squared, and I work it out, then I take the square root. It's kind of easier to do that. So here's your formula. Again, you need to know this formula. You need to know it. The distance squared is equal to the difference in x's, x1 minus x2 squared, plus the difference in y's, which is y1 minus y2 squared. Right? Here are the 2 points right here. You substitute, making sure you put the x values together. That's why I have minus 2 minus 0, and 0. Oh, that's interesting. That really is a negative 4 in there. Let me correct it now. But the end result's going to be the same. It's still going to be a 16 because when you square it, that negative sign goes away. So that was an error. But it doesn't help to see errors on here. So the answer is 20. D squared is 20. Now you take the square root. That works out a lot easier, and you do that a lot in physics and engineering and higher math. The square root can be added later. Work it all out as squared, then take the square root. Makes it just easier to see. So the formulas you need to know. You need to know the formula for slope, which is the difference in the y values over the difference in the x values. You need to know the midpoint, which I'll write with a bar. X mid is going to be adding x1 plus x2 divided by 2. The midpoint in y, remember midpoint will have 2 values. y1 plus y2 over 2, just average those. And the other that you need to know is this distance formula. So you have to memorize those.